Hello, my name is Joey Sheets, and I am the FAA Program Manager with Power Analytics. Today, I'd like to demonstrate on our Power Analytics Paladin system our screen navigation at the Engineering Support Facility for the FAA here in Raleigh, North Carolina. Our first screen is our FAA Acknowledge screen. All users are directed to this screen first before they're able to proceed throughout the Paladin system. So I'll go ahead and acknowledge the screen, and then I'll take us to our first screen default of our floor plan. This is the Engineering Support Facility in Raleigh. Each one of these pieces of equipment is a hot link to the electrical meter of which it is being monitored by. For instance, if you want to look at the electrical meter for COA, which is the critical output bus for UPS System A, you click on the device and you will see the CM4000 meter that is monitoring real time the system at COA. As you notice at the top of our screen, it's very clear where you can navigate to. And of course, this identifies which screen you are on. So, let's go back to our floor plan. And again, you can see the equipment that's being monitored at the ESF and the actual hot links to be able to access the electrical meters applicable to that piece of equipment. Let's now go to our one line. Our one-line screen is divided into two screens. We call this one the main one-line screen. And as you can see, it's the utility fed down to the UOA, which is the output side of the UPSs, before you get to COA and COB. You'll notice that we are energized on the utilities as presented by the red energized buses. The green buses are de-energized. So at this point, we are on utility. UPS systems are all on. Generator is off. And the reason why it's gray is because we don't monitor the generator at the ESF. Let's proceed to the second one-line screen, otherwise known as the critical one-line, the critical bus. And this continues the power flow starting with COA and COB down to our critical loads, which at the ESF are represented by these arrows, and they are actually load banks which represent the CPC loads at a production ARTC. Static switches are demonstrated here, and as you notice, these are gray because we do not monitor the source side, so we present these as gray so that we don't demonstrate something that's actually not being monitored. A side, B side, A side, B side, and such. Continuing along, we'll go to our blackboard screen, which is a representation of our one line. It's our predictive tool, which allows us to run scenarios on the system without actually impacting the live system. Looks very similar to the one line, but you can actually open and close breakers in a virtual environment to simulate power scenarios within the facility. I'm going to go ahead and open up the utility breaker, execute, and you can see what happens when you actually simulate a loss of utility. There you go. Loss of utility. We de-energize all of the equipment prior to the UPSs, but as we see here, the UPSs are still supplying power to the loads. And again, same thing on the Blackboard Critical. It allows you to simulate scenarios within the critical bus structure. Looks very similar to the one line, but here again you have control of your breakers and your loading, so you can do loading scenarios or scenarios of removing power, changing sources and such in a virtual environment. Moving to our energy screens. Proceeding across the top of the screen brings us to our energy screen. Here we demonstrate our real-time and Blackboard simulated energy values to include our cumulative energy values and then our predicted energy values in our Blackboard scenarios. Moving to the right again is our quality screen, and this allows us to see any deviations regarding our voltage, frequency, or power. And when we say deviations, it actually deviates from what we call our predicted power variance, or PPV. Our safety screen is centered around our arc flash capabilities. And from here, we go to our real-time arc flash analysis. And you can actually choose any bus within the system. Let's go ahead and choose USA just for demonstration purposes. And the arc flash label will appear showing us our PPE levels and our arc flash boundaries energy values. So at this point we're at an energy level PPE 4. Right here is PPE 4. Gives us our maximum short circuit kiloamp rating, our boundaries, and identifies the bus and date that we actually ran the real-time arc flash analysis. USA, July 30th, 2013. Gives us our PPE boundary of 209.31 inches. And then, of course, we go to our Paladin reports, which also allows you to not only do an arc flash report, but it gives us our meter daily reports, energy management, some status reports, custom reports. From here we could plot our SCR reports giving us our timestamps and status of our breakers. Legend screen identifies all of the icons within our system to allow you to understand what the actual legend means. The loads again, which I pointed out before on the one line, generator, energized, de-energized buses, etc. Then our last thing is our alarm screen. This is the typical alarm screen presentation that we provided in the past through our other systems: critical alarms, cautionary alarms, and acknowledged alarms. We see at this point we have 10 critical alarms, PPE alarms on one of the static switches, and we have some alarms on the Albert UPS system, which I believe are down. They're not talking to the Perseer system, which is why we have this alarm. We have a acknowledged alarm, a cautionary alarm, what tells us we have a new waveform capture on static switch F. So that, in a sense, gives us our navigation around the facility using the Power Analytics Paladin system here at the ESF. Thank you.